Hello, class. Welcome to Mapping Lab 3, Projections and Coordinate Systems. Hopefully you guys are feeling okay about everything in the semester. We're going to start off with going into Learning Suite. We're going to need this right here, this zipped data file, which should work. We're going to test that out right now to make sure it works. And then we're also going to go back to Mapping Lab 1 and get these demo XY coordinates. So yeah, and that'll make more sense right now. I've opened ArcGIS Pro. I'm gonna click map, do our regular shindig. This is map lab 3. But notice how this automatically goes to fs.kdum dot this like web thing. We don't want that. Remember, never use the J drive, never use this, anything that starts with fs.kdum.et.byu.edu. We're gonna go to the C drive. Or we could go straight to downloads. This time I'm actually gonna go straight to downloads because we're gonna test that out. And let's make a folder for fun and call this lab 3. Lovely. Okay, I guess we don't need to make another folder. There we go. Opening the map. Okay, so typically at this point, we will change the projection, but today we're gonna learn all about projections. And so we're actually gonna leave this one the way it is and start with making a new map and another one, and we'll make another one. So now we have 4. We're gonna rename the map itself. This is just so that you can stay organized. It's kind of an optional step, but this one is going to be WGS 1984. And that matches with the projection that it currently has, so we don't need to change anything. Map 1, though, we got to change. This one's going to be our good old friend UTM zone 12N. So we got to go in here, properties, coordinate systems, and we'll change it to my best friend 12N. Awesome. Okay, then we also got Albers equal. And you should have watched the video that Dr. Ames posted. If you're watching this video in fall of 2021, then Dr. Ames was sick, and so he wasn't able to do class, and so he sent out a video. Otherwise, you'll cover this in lecture in future semesters. Okay, so yes, you should have already watched that so that you kind of understand what on earth we're doing. So this one's going to be Albers equal. If you haven't watched it yet, no big deal. Just watch it later. Equidistant. Awesome. So now we have these 4 projections, which is all we need for now. Let's make sure, let's change this to Albers equal. North America. And we want USA contiguous Albers equal conic. This one. This one's kind of a crazy projection. It's probably unique. Probably haven't seen that. Once it loads, yeah. Then equidistant. Projected. And this is going to be continental. We want North America. And we want this USA contiguous equidistant conic, that one. Okay. Awesome. So now let's actually add a folder connection to wherever I put I went and downloaded these ones, but I'm not sure where I put them. Oh, they're in downloads. Okay, so I'm gonna just put it straight to downloads is gonna be the folder connection, like this. And then from there, I also need to unzip my file. Got to extract all the data from there, and that works. All right, so now let's see what is in this folder. Looks like we got mapping lab geodatabase. That's awesome. We are going to want to use that. So we're going to put that into our databases. Or if you want, you can just drag these straight on. I'm just going to do Tisset, Indicatrix, and state boundary for every single one of these. Okay, so now we have those circles and the states for everyone. Oop, did I put it on this one? Doesn't look like I did. Awesome. And this shows distortion. So the circles should all be like this, or they would be if the projection didn't have to distort it a little bit. So as you notice, if you go south, it becomes more wide, more and more wide. And so the distortion is on the x-axis. And as you go north, same deal. It becomes a little bit more distorted in the x-axis. But let's look at Albers equal. Albers equal does a really good job of not having very much distortion for this whole range, but it has a crazy distortion at the north and south poles. UTM zone 12N, now you might be able to see why we use it, because there's pretty much no distortion anywhere. Yeah. And then WGS 1984 has this horizontal x-axis distortion. Even here, even in the States, it's not perfect like it is at the equator. So now it's actually as simple as making a map out of this. New layout, letter, and look at the lab document for exactly what, how to do this. But essentially, you just want to have all your maps here, and I'm not going to do this pretty. You want to have all your maps. And make it pretty and stuff. Oh, our looks like this one. Which one is that? Equidistant is missing our state boundary. Awesome. And let's put the Tisset indicatrix on top of the state boundary. Awesome. So now in our layout, like even this out, make it look good. A quick thing for activate, you can like activate and then just go like this, zoom to layer. Oh, but it looks like it might have the Hawaii in there too. So that might not actually work. So here's another trick for you. You can select California and Maine. Oh, but I'm gonna push the shift button, I think is what it, there we go. Shift button. So select both California and Maine, and then you can go like this and go to selection, zoom to selection, and it'll zoom perfectly for you. So I would do that with all of them. We also want to change the base map. The base map should be imagery. Awesome. And that's looking perfect. You're going to want to add label, like names to all of these, and north arrows. You don't need a scale bar for each of them. But you need, basically, I want you to recreate exactly what's in the lab document. So north arrows, imagery background, the colors of the states don't need to, like the colors of the states in the lab are like green. That doesn't matter. That color doesn't matter. And I have a title above each of the map frames, neat line, all that. So look at the lab document to see how to replicate that. But this looks pretty good. And I would just do the same for all these and like even it out and add the labels. So that is the first, like the first map. Next, we're gonna do the second map, which has a lot of adding XY point data, which you may hate. And you will especially hate if you're using the J drive by accident, because at this point, it'd only be an accident. And we're gonna go into Excel. And we're gonna make what's called an origin locator. Very simple. It is a very simple concept. We go X, Y, and then this goes 0, 0, and that's it. And then we'll export it. We're gonna save it as a CSV, just so it goes a little faster. I think it would work technically with regular this guy. So now we have points. Now we have points, like when we import that file, that will show us exactly what 0, 0 is in each of these projections, and that'll give us a good idea of how things work. So we're gonna go back to our good friend UTM zone 12N, and we don't care about these ones. We will have already put base map as imagery. Awesome. And then we're going to add data, XY point data. Now this right here is for the big leagues. You may not know how to do this yet. I didn't even label it. So this is our origin indicator if you wanted to save it with a name. And I'm going to drag that right in there. And that's it. I'm going to set this to current map and run. Notice that it's coming from the C drive and going to the C drive. They both need to go from and to the C drive. Completed with warnings. Let's see what's up. Invalid geometry. Well, let's take a look and see where it is. Let's try this again. Let's see if I did this right. X and Y, 0, 0. Sometimes it's just really hard to see, so I'll make it big. Nope, I don't know why I chose cemetery. NAD 1983 UTM zone 12N, and then this projection is, it matches the projection. Okay. Okay, so that's weird. Just double checking some things. I'm gonna figure out what's wrong. Okay, I think I figured out what was going wrong. It was really weird, but I just set this to be 1, 1 instead of 0, 0. So it's off by 1 meter. Well, one meter in the X direction and 1 meter in the Y direction. So yeah, weird. It wouldn't let me do with two, like with zeros. So that was weird. Anyway, so there we go. I've put in my origin locator. I can I'm gonna remove all of these old things. Okay, add data, XY point data. And now I'm going to do the same thing, but with my demo coordinates, and you can use your traverse coordinates, just something that is in, Provo. There we go. There it is. And now we're going to go out of this again and do XY point data. XY point data. I had to go out and back in, otherwise it would overwrite what I had before. And I'm going to do our origin locator again. But this time we're gonna do this in 11N instead of 12N. So 11N is for Nevada, is where like Nevada will be perfectly undistorted. And there it is. And so you'd expect it to go to the left, right? So let's put it in and see what happens. Origin locator. This completed with warnings is just there because I had some 0 dots. And so it just didn't add those, but it did add this one. XY 1 1. It's a weird thing. I don't know why it's doing that, but oh well. If you can get it to work with 0 that works too. But this will be the solution that I'll give you if you can't get it to work with 0 okay, and then we're gonna go out again, open up XY point data yet again, and put in our demo coordinates. And we're gonna put it in 11N, which is the same as origin locator table in this one. So you put it back in 11N, and look, now we have that. Perfect. Okay, so we have our origins of zone 11 and 12, and we have our Provo points for zone 11 and 12. I would label them. So now this is going to be part of the map. And so when you go to make it, you're going to have a legend and you don't want it to have all this ugly whatever. And so I would label them. So this one is 11N. And we can say Provo points if you want. You can kind of label it as you feel. This one is 11N origin. This one is going to be 12N Provo points. And this one will be 12N origin. Awesome. Okay. I would also change the symbology. So let's make the Provo points be a different color. Sorry, let's make the 11N be a different color. Instead of blue, let's make them be red. Okay, so now we're all prepped and ready for the map. We've got another map to make, and this one is going to be in the Lambert conformal conic, which hasn't been created yet. So we're going to go to insert, new map, create another one, call this one Lambert conformal. That's kind of optional. Like I said, it's just to keep organized. Properties. And it's going to be this one. Okay, let's add a base map. And let's bring in XY point data. And we're going to do the same thing that we did before. So origin locator. Let's do the origin locator in the current map. Run. Look, this origin is like in Kansas or something. So that's where it should be. We're going to use current map here. And it should be up here, like Hudson, even north of the Hudson Lake, or what, Lake Hudson, is that what that's called? Yeah, all the way up here. That's perfect. And now we're going to do traverse coordinates, our demo coordinates, but in 12n. And so because it's a different projection, it'll be off from the base map, but surprisingly not very much, because now it's no longer connected to the base map at all because it's a different projection. So we already did this. So if we use this coordinate system, it's going to treat this as the origin and go north and east, that as we like the amount that is said in this spreadsheet, because those are basically just coordinates. But if we change this so that it says 12n, it's going to have a different origin. It's going to have that origin that 12n has. And so even though the map is different, it's still going to show up pretty much like generally around Provo-ish. Yeah. And because there's distortion, it shouldn't be perfect, but it's pretty dang perfect. So that's pretty great. Okay. So now we have everything that we need. We're going to change the colors so that we can understand, because yeah, I might do these two in the same color and change this one. We're also going to change the names so that they make sense. I might even have them be different colors from the first map, because you're going to have a legend and you don't want to get confused. And also they're not really easy to see. So a lot of this is up to you. Then when you go to make your map, let's just show you how to do that. When you go to make your map, you're going to do the same thing, but you're going to use 12n. Yeah. And you're going to, you got to activate and like zoom out and move it so you can see them both. There's a great example in the lab document of how to do this. So there you go. And now you're done with the second map. So now we're gonna talk about how different projections will have different measurements of polygons and areas and stuff like that. So we're going to put this in zone 12n. And notice this one that we didn't use, this cadastre. Let's zoom in and see what this is. So this is every single property line in Utah County. So pretty dang cool. Right off the bat, I'm just gonna, for me, make this be more transparent so I can see what's going on below. Yeah. Anyway, just make this black so I can see it better. Okay. So what we're gonna do here, we're gonna go map and measure features, and we're gonna measure the area of some features. So let's change this to be square. What do we want this to be? Let's make it be square miles. Okay. So let's look at the deliverables for a second. Okay. So create a table like the following and fill in the cells with your measurements you made using the measure tool. Use the dimensions specified in the table. Convert or make new measurements if necessary. So that one we need the state boundary for. So essentially what we're going to do is measure Utah in square miles and write down this number for 12N is this one, and then go to WGS and do the same thing. Write down that number, go to Albers equal. Make sure that this says square miles. Yep, write down that. Notice how they're kind of close, but they're not exactly the same. Change this to square miles. So you're writing down these numbers in the following: 12N, Lambert conformal, which is this one. So we got to put on, we need to put on the state boundary and measure square miles. 12N, so we've got 12N, Lambert conformal conic, the US contiguous equidistant conic, and the Albers equal area conic is for that first one, number one. Okay, and the next, create a table for the following area and measure different land parcels in Utah. So we're gonna also add this cadaster to this guy. Let's uncheck the other ones. And we're gonna compare kind of more small scale stuff. So the three things we're going to do are your apartment, a restaurant in Provo, and the Provo City Center Temple. So let's start with Provo City Center Temple. Let's see, that should be like here. It's kind of hard to see. So I could make it more transparent too, would probably be good. Okay, so here's the Provo City Center Temple. So be sure to erase and then select the Provo City Center Temple. And then you're also going to do your apartment and a restaurant in Provo. And that's going to be, yeah, basically you just click on this and write down this one isn't going to show anything for square miles. So you're probably going to want to do square feet for that one. Square feet for number, like the second part of number one. And then you're done with that one after you do it both in Lambert conformal and UTM zone 12N. So we're comparing those two and we're going to see if they compare well. And then number two, suppose the actual area of Utah is 219,887 kilometers squared, which you can convert into square miles, or you could measure all of those in kilometers, whatever you want to do. And the actual perimeter is 1995 kilometers. Write a short paragraph commenting on which projection is best for preserving shape, area, and size. Describe the outcome of your observation in the Tissot indicatrix exercise. So that's talking about these circles, these ones. What do these circles tell us? Awesome. Describe in your opinion, which projection is the best overall? Yeah. So number two will be a lot easier after you watch the lecture, because he talks all about preserving shape, area, and size. Then number three, include the two maps you created as outputs for manipulating spatial data. Do not screenshot these maps. Yeah, so that means once you finish your layout, you go to share and export it as a PDF, combine the PDFs and submit it to Learning Suite. Yes, the first map only needs the 4 map views, a neat line, titles for each frame, and a north arrow for each frame. But the second map needs all cartographic elements as outlined in lab instructions. All these items should be submitted as a single PDF file. Combine them together. Do not include the lab document. Do not attempt to submit your lab in any other format other than single PDF. Kind of the regular thing. And I believe that's all. Yeah, and then you're done. Anyways, so if you have any questions, then you have my information, my email on Learning Suite, or come to my TA hours. And excited to see you in lab. See ya.